In our previous video, we were talking about a velocity problem, and this was the formula that we had built. So in this question, it's saying if nobody catches the ball, when will it basically land? So it says how long will it be in the air, but that is the same thing as saying when will it land. So that means that we want to equal it to 0. So this is when we want to use our quadratic formula, and we're going to go ahead and plug these numbers in to that formula. Then we're going to compute our discriminant, which is a really big number. And with the word problems, we're always going to just round this. So after we get our discriminant, we're going to go ahead and type in the square root of that number. And it's about 86.5. And since these are always going to be like terms from here on out, we're going to go ahead and break it into two cases. So we're going to use the plus for case 1 and the minus for case 2. And again, if you type this all in one step in your calculator, you want to put the top in parentheses. So if I type this in my calculator, I'm going to get negative 0.05 for the first one, and I'm going to get 5.4 for the second. Now, the ball can't be in the air for negative seconds. So we're going to cross out this answer right here. We're going to reject this one, and we're going to go with the 5.4 seconds. And then letter E is saying, what was the initial height of the ball when it made contact with the bat? That means the starting height, the beginning height, and that is the y-intercept. So they just want C. And because this is in standard form, I have C, it's just 4. So that ball was 4 feet above the ground to start out. Right. Our next problem is a dropped object problem because there's no velocity, there's no force behind this object. I'm simply holding a coin out and I'm dropping it. All that they're going to tell you is how high the object is off the ground. So it's 450 feet in the air, and it wants you to write a function in terms of seconds that models the height of the coin, blah, blah, blah. So we're going to use our dropped object formula, which is negative 16t squared. All you have to do is plug in your starting height, which is 450. Okay, so we're just going to pretty it up a little bit. H of t equals, and then put your formula right here. And that's it for part A. All right, part B uses the word ground. When will the coin hit the ground? That means we're going to equal it to 0. All right, so I'm going to take my formula, I'm going to equal it to 0, and I'm going to solve. Now, there are not 3 terms in here, so you do not have to use the quadratic formula. So you actually could use the square root method here because you can get t by itself. You only have one term that has t in it. So you could use the square root method. Now you're welcome to use quadratic formula. You'll just have to use 0 as your b because you don't have a middle term. You have the t squared dude and you have the guy with no letter, but you don't have a term in the middle. So those are your 2 choices. The square root method is probably quicker. So that's what I'm going to do. I'm going to start by subtracting 450, and remember, this is backwards PEMDAS. So we're going to subtract, we're going to divide. This is where I would get out my calculator, and it's about 28.12. And then we're going to square root both sides. And because it's a word problem, I don't need to use the plus minus symbol because I would throw the negative answer in the trash anyway. So the answer is going to be positive 5.3, about. All right, our next example is about a volleyball player who spikes the ball downward, that's important, with an initial velocity. So there's some force behind that ball, of course, you're spiking it. That's 39 feet per second from a height of 8.6. And it's going to always say, write a function, h in terms of t. That just means write h of t equals. So we're always going to have this part. We're going to plug in our initial velocity and our starting height. Because it's downward, we're using the minus symbol. And letter A is done. Letter B is saying, how long does the opposing team have to react before the ball hits the ground? So there's the word ground. which means we're going to equal the problem to 0. All right, so now we're going to use the quadratic formula. So you're going to plug all of this right into your quadratic formula and go through the motions. All right. The discriminant's going to be about 2071.4. And then we're going to square root that. It's about 45.5. And then we're going to case 1, case 2 it. All right, so if I type this in my calculator, case 1 is going to be 0.2, and case 2 is negative 2.6. And since you can't have negative 2.6 seconds to react, that doesn't make logical sense. We're going to go with the 0.2 seconds. So they don't have a lot of time to react to that ball. All right, so I'm going to let you guys try this one on your own. Let's just start with A and B. All right, so you're going to build your equation first so that you can actually answer those problems, but you figure out what you're being asked to find and then go ahead and find them. And then we'll do C and D together. All right, so go ahead and pause the video, give it a shot, and then just unpause when you're done. Okay, so letter A is asking for the max height, which is K. And letter B was asking when does it reach max height. So it actually made sense to do letter B first because that's H. So H is about 2.9 and K is about 138.4. Now letter C is saying if a player catches the ball from a height of 8, how long will it be in the air? Now, typically in the air means equaling it to 0 because I want to know when it'll land on the ground. But the ball's not landing on the ground, it's landing in someone's hands at 8 feet tall. So all that means is instead of using 0 for on the ground, I'm going to use 8 because that's how high it is off the ground. So it's like ground plus 8. All right, so whatever the height is that they're giving you, that's what you equal the problem to. All right, so we're going to set this equal to 8, and we need to move the 8 over because it has to equal 0 to use the quadratic formula. And then from there, we just plug it in the quadratic formula. And just to fast forward a little bit here, I'm just going to tell you that you're going to get about 91.4 towards the end there. And then when you do your case 1 and case 2, you're going to get 2 answers for this. You're going to get 5.7 and you're going to get 0.03. Now that's a little weird because usually we get a negative and we get a positive. So why are we getting 2 positive answers, and how do you know which one to go with? Right? Kind of weird, huh? So I want you just to kind of visualize right now. The ball is hit right here from a height of 4. It's going to go up, and it's going to come down, that kind of thing, okay? This axis would represent your seconds, and this axis represents your feet, how high it is in the air, okay? So as time goes on, the ball gets higher and higher and higher, right? And this line right here, this represents 8 on the y-axis. Now, if you look, the ball is going to touch that 8-foot height twice, okay? It's going to touch it right here on the way up, but then it's going to surpass that 8 feet on the way down as well. So that kind of makes sense. The ball's going to be 8 feet in the air, 0.03 seconds into the travel, right? That's on the way up. But then it's going to come back down and pass that 8-foot line back on the way down at approximately 5.7. Now you have to use your own reasoning here. If someone's going to catch it, are they going to catch that ball on the way up, or are they going to catch it on the way down? So I've never seen anyone in my entire softball career catch a ball on the way up. So ball's hit, player's going to catch it on the way down. So we're going to go with this answer right here. All right, we're going to catch the ball on the way down. So that would be the 5.7 seconds. All right. Now, letter D is actually saying, when will the ball hit the ground? Assuming no one touches it. All right, so they didn't give us a different height to use, so we have to use 0. But everything else is the same. We're just going to plug the numbers into the quadratic formula, and we're going to crunch it out. And again, just to save on time, these are the numbers that you're going to get eventually when you do your math, and you'll get a positive and a negative answer. That one's a little easier to figure out which one to keep. And that's it.